Okay, now we're going to talk about damped trends. And this is another technique that's pretty widely used in practice, because the idea here, if I have a trend term, trends don't go on forever. They don't continue unchanging indefinitely into the future. In fact, in most cases, they kind of dampen, they kind of taper out a little bit. And so using a constant linear trend, like we did in the previous example, can lead to over forecasting. And this is especially true if we do a longer forecast horizon. Instead of doing next month or next week, what if I do 20 weeks in advance or 6 months in advance? So as I go further out, I might have more problem with my trend term, because if I just use a linear trend, I'm assuming it doesn't change over the time horizon of my forecast. So what the damped trend model does, it says, you know what? There's going to be a little bit of dampening to it. It's a slight modification to the exponential smoothing model, and we're introducing yet another parameter, and we're going to call this one phi, or phi, and it's going to be equal between 0 and 1. And so if it's equal to 1, then this means it's just a linear trend. And let me show you what we mean here. So my forecasting model, and again this is just a slightly modified Holt model, is going to be equal to, here's my forecasting. It's going to be the forecast sitting in time t for t plus tau, so I'm going tau units in advance in the future, is going to equal to my most recent estimate of the level plus this term. Now let's look at this. We know what the beta hat t is. That's my most recent estimate of what the trend is going to be. But I'm going to multiply that by this phi to the ith term. So look back to where if phi is equal to 1, and what I'm doing here is I'm summing this term for each of the periods I'm going into the future. So if tau is 5, then I'm going to sum this I equals 1 to 5. And so it'll be phi to the 1th times beta t plus phi squared plus phi cubed and so forth. Now if phi is equal to 1, it doesn't matter. So this would be equivalent to tau times beta t. Again, that's if phi equals 1. But if it's not equal to 1, it's a little less. So what does that mean? That means since I'm raising this to the ith term each time, it'll be reducing that trend as we go further out. Again, that's the dampening effect. Because if I have some number that's less than 1, and I'm squaring it or cubing it or going to the 4th, that's going to be a less than 1. And so I'm going to be dampening that trend. Now my updating procedures change just a little bit. So for my level, it's going to be alpha times my most recent observation, just like normal. 1 minus alpha times my old information. What's my old information? It's going to be a hat t minus 1, which is my estimate of the level last time period, plus this phi times my estimate of the trend in one time period ago as well. So all I'm doing is using this phi to modify my most recent forecast or estimate of the level, of the trend rather. So then the update of the trend term itself, b hat t, is going to be equal to beta, that smoothing term again, times alpha hat t minus alpha hat t minus 1, which again is the most recent level estimate, subtracted by the second most recent estimate of the level. And I'm going to add to that 1 minus beta times phi times that beta hat t minus 1, where this phi beta hat t minus 1 is just the dampening of that level estimate trend b hat t minus 1 of the previous period. So it's pretty straightforward. It looks a little confusing, but all you're doing is slightly dampening future trend estimates. So let's look at an example. And this is the same example for that part VMI 1984. And what I want to do is build a spreadsheet for next month estimates for the next 8 months. And this time, I'm going to use a dampened trend. And I've got the same data has been used. So this information in column C is the same data that was shown in the previous example. So what do I have here? Well, my forecast for time sitting in time t for time t plus 1, so again it's the next period forecast, is simply again going to be this a term, d6, right, 28, plus beta, or b3, which is my phi term, right? That's what's sitting here in cell b3, times my estimate, my most recent estimate of the level. So let's look at the very last observation. Let's look down here at row 15 for October. and see if we can understand what we're doing here. So this is saying my estimate for the level in time t, that's October, is going to be equal to what? Well, the value in B1 is just simply the alpha times C15, and what's in C15? Well, my most recent observation. So it's alpha times the most recent observation times 1 minus alpha times what's in D14, which is my most recent level estimate, 34.59, plus that phi term, 0.9, times what's in E14, which is my most recent estimate of the trend. So again, all I'm doing is dampening. That's the only difference here. I'm slightly dampening the most recent observation there. So then what am I doing for the level? Well, it's the same thing. This is the beta term plus or multiplied by the difference in the most recent level estimates, right? D15, 35.31 minus 34.59. That's my most recent new information for the estimate of what the new trend would be. I'm going to add this to 1 minus beta times that phi value again, which is in cell B3, times E14, which is what? The most recent trend estimate. So that's the new trend information and the old trend information slightly dampened. All right, so that's pretty straightforward, and the mechanics seem to make sense, but let's look at what this looks like on a chart. So if I look at next month forecasts, and again, here's the actual in blue, and then the linear, what we had done previously, this is what it looks like for the next forecast. And then this is what the trend looks like. So in each cell here, this is actually the forecast in each of these cells. So with the green here, this is the forecast in February, or in January for February. And so you can see what the errors are by just the vertical distance. So what we have here, we can look at the mean square errors, and the linear, which is in the red, the mean square error is 4.52, and this again is smoothed using an omega term, and the dampened is 3.8. Now obviously this is very specific to the data that you have. If you have something where it's a steady state trend, then it's going to, the linear, it'll be a linear trend. But in practice, you see this happen quite a bit, and even more so when you look at a longer forecast. So let's say what happens if I'm sitting in January, right? I'm here in January, and I'm making a forecast at the end of January for the next 9 months. So I want to make a forecast for February, March, April, May, June, and so forth. So there's what the actual demand is going to be. We don't know what that is yet because I'm sitting in January. Here's what the forecast is going to look like for the linear trend. Notice it's a straight line. It's a linear trend. The dampened trend, though, is going to say, okay, so I'm sitting right here in January. This is my forecast for February. Each subsequent month, I'm going to have a slightly tapered forecast. So again, this is just another technique that is often used in practice, and now it will be used within your forecasting tool that you actually use, but I wanted to show you how it actually works in the mechanics. That's why I wanted to show it to you in Excel.